Good morning, everyone. Welcome back to another video on Math 105. This is Mike. In the previous video, we talked about exponents, the order of operations, and inequalities. In this video, we're going to talk about variables, algebraic expressions, and equations. So to kick it off, some terminology. A constant is another term for just a fixed number that does not change. That is to say, any number whatsoever. I have some samples down here, 5, 10, 11 thirds, 4 sevenths, minus 4 thirds, just any fixed number. A variable, on the other hand, is a symbol, and we virtually always use letters, and it's used to represent an unknown number, an unknown quantity. Examples that we typically have, A, T, X, and Y. Now, this variable can take on different values if we're talking about an equation that it's in. If we're talking about an algebraic expression, which we'll get to very shortly, we could take sort of any number whatsoever, any constant, any fixed number, and substitute it in for the variable. And what we get out then will change. So when we take constants and variables, one or more operations, and potentially grouping symbols as well, and we put them in sort of a logical sequence, we get what's known as an algebraic expression. And we have some samples of some algebraic expressions right here. We see we're just some basic adding of things, subtracting of things. Here we have an exponent in this one, and we're doing some dividing here. One quick note I want to make, we're seeing things like 3x or 3t or 10a squared or the 2a there. When we have a constant multiplied by a variable, we just write the constant first and then variable second, and we don't put the dot there to show the multiplication. It's just standard knowledge that if you write a number and then a letter, it's a constant times the variable that you have there. So I just wanted to clear that up in case any of you had any questions on that. Now, when you have an algebraic expression that contains a variable or variables, we can evaluate them by substituting a specific number in for the variable and then using our order of operations. So we're going to evaluate some algebraic expressions for when the variable x is equal to 2. Kicking it off with this first one here, 5x squared, or 5 times x raised to the second power, plus 1. I'm going to take that value of 2, and that's going to replace the x. So that's equal to 5 times 2 squared, or 2 to the second power, plus 1. Now, the common error that people will make here, and I'll purposely show you, a common error that people tend to make is they would think that this exponent of 2 goes to both the 2 and the 5. And they would say that this is equal to 10 to the second power plus 1, and then 10 to the second power is 100. That is not the case. When you have a constant times x raised to some power, or a constant times some other constant raised to some power, that power only goes to that second constant there. So this exponent of 2 only goes to this 2. It doesn't go to both the 2 and the 5. So what we actually have here is we actually have, after I clear that out, we actually have 5 times 4 plus 1. And if we use our order of operations, we see that this comes out to be 21. Do the 5 times 4 first, that gives you 20, and then add on the 1 there. Second one here, 2x plus 3, all divided by 7. When you see something written like this, where we have multiplication and adding and all that stuff happening on the top, and we are dividing that whole thing by something on the bottom, secretly we have grouping symbols up there on the top. We don't actually write them out for something as basic as this, but secretly we have grouping symbols there. So we do have to take care of the top first, and then we would divide what we have there by 7. So I have 2 times 2 plus 3. And that is all being divided by 7. Using the order of operations, everything in here has to be done first. So 2 times 2 is 4 plus the 3 divided by 7. 4 plus 3, as we all know, is 7. And 7 divided by 7 gives us 1. So this third problem, I'm going to let you try that problem on your own. Substitute in 2 for x, and we'll see what we get when we go through it in class. Something that's a little bit more involved, a little more complicated. We have algebraic expressions here now where there's 2 separate variables showing up. We have t's and y's happening here. So it's going to work in the same way. We're going to substitute specific numbers in for these specific variables. But now we just have to make sure that we plug in the right number for the right variable. If I look at the first one here, 4 times y to the second power, or y squared, plus 5 times t minus 4. All right, the 1 is taking the place of any y's. So here, the 3 is taking the place of any t's, which would be there. So this is 4 times 1 squared plus 5 times t, which is 3, plus 4. Again, order of operations now. And once again, this exponent of 2 only goes to the 1. It doesn't go to the 1 and the 4. So 1 squared, or 1 times 1 is 1. So I have 4 times 1 plus 5 times 3. My apologies, this is a minus. These are minus 4s. Multiplication, 4 times 1, 4, plus 5 times 3 is 15, and then minus the 4 once again. And now add or subtract, going left to right. 4 plus 15 is 19, minus 4 is equal to 15. Second one here, y times t squared plus 7 times y times t. Again, we're going to substitute in the proper value in the proper variable. So y, 1, times t, is 3 squared, plus 7 times y, 1, times t, 3. And now I'm actually going to stop here, and I'm going to let you solve this problem on your own. Next up, a really key skill that you're going to need in this course is to be able to take words and translate them into mathematical symbols, mathematical expressions, mathematical operations, anything like that. And there are certain key words or key phrases that when you hear them, they should be triggering certain kinds of operations. For example, seeing the sum of blank and blank, or seeing adding blank and blank, is sort of the English cues to say, okay, we're going to add stuff. If you see blank minus blank, or you see blank subtracted from blank, or you see the difference between blank and blank, you know, those things should make you think, okay, I'm subtracting these things. And you have to be a little careful when it comes to some of these phrases for subtraction. If you see the difference between blank and blank, then you have first blank minus second blank. If you see blank subtracted from blank, what's actually happening there is it's second blank minus first blank. So you have to be a little bit careful when it comes to the key words and key phrases for subtraction. I have a couple samples here to show us the difference between these two phrases there and what they actually mean. What are the key words or phrases for multiplication? If you see the product of blank and blank, or you see blank times blank, that's saying, okay, we have multiplying happening here. Case in point, the product of a number and 7. If you see the product of a number and something else, this phrase right there, a number, this is a common phrase that we use to stand for any variable, which I chose in this case x. So if you see a number, that's an unknown number. It's this unknown quantity that should make you think, okay, variable. And lastly, if you see blank divided by blank, or the quotient of blank and blank, that should make you think, okay, I have to divide these two quantities. So a couple samples here. A couple samples that are more involved, a little bit more complicated. The quotient of a number plus 2 and 5. Now, this does require some careful reading. When you see the quotient of a number plus 2 and 5, the quotient of a blank, or when you see the quotient of blank and blank. So here's my first blank, there's my second blank. The quotient of blank and blank says, okay, whatever is in the first one here, that's what goes on top. Whatever in the second one here, that goes on the bottom. So I know 5 is going to be on the bottom. How do I represent this top part here? Well, I have a number, which as we just said, is the common phrase used to stand for our variable. So x, a number plus 2. So blank plus blank says we're going to add those two things. So this is x plus 2, all divided by 5. Second sample, 4 times a number plus 10. Okay. Again, 4 times, or 4 multiplied by a number. This right there is saying, all right, we are multiplying these two quantities. We're multiplying 4 and a number. So 4, and then again, a number is the English cue for our variable, which I'll, again, just choose x. And then we have that thing plus 10. So it's this thing, and then we add 10 onto it. The third one, I will let you try on your own, and we'll go through that problem in class. Now, Something that's often confused with an algebraic expression is an algebraic equation, or just an equation. And an equation is really just a mathematical sentence. And in an equation, two expressions are set equal to each other. And this is the key difference between expressions and equations. Equations contain equal signs, expressions do not. And how do we sort of take a sentence and translate it into an equation? We're looking for a particular keyword, and that particular keyword is the word is. The word is the keyword for the equal sign, and that shows that we have an equation. You could also see the word equals there, and that's a more obvious cue. Case in point, the sum of a number and 8 is 15, or equals 15. That is saying the same thing, but now in math, as the sum of a number and 8, x plus 8, equals 15. So this one here, the difference between 5 times a number and 2 is the same number. So there's our equal sign there. The difference between 5 times a number and 2. Well, a number, again, there's our variable, our x. So I have 5 times my number, 5 times x, and it's the difference between that and 2. So I'm subtracting 2 from that guy, equals, and then it says the same number, the same thing as what this guy was, and that's x. So this is our equation in this particular case. All right, now what can we do with algebraic equations? We want to find solutions to them. What is a solution to an algebraic equation? It's a number that makes both sides of the equation the same. And we can check that a particular number is a solution by substituting the value into the equation, and if both sides are equal, then we know that it is indeed a solution. So we're going to determine if the number that is given is a solution to the given equation. So here I have 2x minus 5 equals 13, and we're going to see if x equals 9 is indeed a solution. So I'm going to take the 9, plug it in for the x. So I have 2 times 9 minus 5. And I put the question mark over the equal sign because we don't know if this is true. Some of us may know that, some of us may know whether or not this is actually true, but for the sake of this problem, we don't know yet. So, working with the left-hand side, 2 times 9 is 18, and then I still have that minus 5. Again, using the order of operations. And 18 minus 5 is 13. So we do indeed see that 13 is equal to 13. The two sides of this equation are the same. So yes, 9 is a solution to this equation here. Let's go to the next one. 5 minus 4x equals 10. And we're going to see if x equals 3 is a solution. Well, again, take the value, plug it in for the variable, see if the two sides are equal. 5 minus 4 times 3, is this equal to 10? We've done enough sort of basic use of order of operations here to see that we are going to come up with 5 minus 12 there. And this is negative 7. and -7 is not equal to 10, so this is not a solution. X equals 3 is not a solution to this particular algebraic equation here. And the third problem, I'm going to let you try that one on your own, and we'll go through that guy in class. So this concludes our video on algebraic expressions and algebraic equations, as well as talking about constants, variables, and those key words or key phrases that tell us what operations we have to do. If you have any questions or comments, be sure to reach out to me, guys. Send me an email, stop into my office, give me a phone call, whatever you have to do. Otherwise, until the next video, take it easy, guys.